OpenRefine for health sciences and health information professionals. This is the first of two sessions that cover everything needed to get started with OpenRefine for data cleaning. And my name is Sarah Gonzalez. I'm a data librarian with Northwestern University's Galter Health Sciences Library and Learning Center, as well as a staff member of the NNLM's National Evaluation Center. Today, I am joined by Christine Hislop, Data Services Librarian at the Health Sciences and Human Services Library, University of Maryland, Baltimore, who will be co-instructing, and also Javier Martinez Rodriguez, Program Specialist, and Justin De La Cruz, Associate Director, both with the National Center for Data Services at the NNLM, which is based at NYU Health Sciences Library. And they'll be helping us out today with questions and in chat. So this series will ideally provide you with everything you need to get started using OpenRefine for data cleaning and transformations. In this first session, we'll explain what OpenRefine is, what it does, and try to get you familiar with common operations in the program, from importing and exporting data to faceting and clustering. Session 2 will explore transformations, which are different ways of manipulating data in columns. For example, you can eliminate white space in cells or transform text to lowercase or uppercase. So this is the list of topics that we will cover today in part 1, just to give you an idea of the scope of this first session. After introducing what the program is, we will cover where to find things within OpenRefine, the basic features it has available to you, and give you a quick look at transformations before we really focus on those at another time in session 2. So today we will cover importing data, layout and menus, working with columns, faceting and filtering, clustering and exporting data. Our learning objectives for today's session 1 are to summarize OpenRefine's uses and applications, to import and export a data file successfully, to utilize data manipulation options available in OpenRefine's drop-down menus, including facets, filters, and clustering, and to apply undo-redo actions to data transformations. OpenRefine is a powerful, free, and open-source tool that can be used for data cleaning. It is a program that installs and runs on your computer and runs within your web browser. You will need to download and install it, but after that, you do not even need an internet connection to use it. OpenRefine allows you to save all of your workflows for data cleaning, meaning that you can reuse them when you need them. You can also share your OpenRefine projects with others. For example, when submitting your data for publication or other purposes, you can share your OpenRefine project file, which contains all the steps you took in cleaning your raw data. And I believe that everyone has received an email prior to class about how to install, so I hope you've had a chance to try that out. So OpenRefine, what does it do exactly? Well, it was designed for cleaning data, so it is good at importing data in different file formats, such as CSV, Excel files, text files, XML, and more. It's good at giving you a visual overview of your data. It's good at finding and updating inconsistencies in data labels. So for example, with dates, be they listed in month, day, year format versus day, month, year. Or also inconsistencies in words that might have different abbreviations. For example, either the 2-letter or 3-letter abbreviation for certain states. And it also is good at fixing typos. OpenRefine is good at splitting data into different parts, such as making a cell that's currently listed first name, last name, both in one cell, splitting them into 2 separate cells, one for first name and one for last name. The program is good at combining data sets, and also it's very good at saving a set of data cleaning steps that you can reuse over and over again on different files. For example, if you have survey data where you download the data monthly for processing, you can save common data cleaning steps that you use every month in an OpenRefine file and rerun them when you need to. Just as important, it's good to know what OpenRefine does not do. So OpenRefine is not useful for data work outside of the data cleaning phase. which can be viewed as the preliminary stage of data analysis. So, for example, OpenRefine is not useful for active data collection. It's not useful for adding new data points into existing data files. It will not help with data analysis like statistical tests. It won't generate data descriptions or data annotations for you. And outside of sharing your data cleaning steps, it won't actually help with the other portions involved in data sharing. So now let's look at some OpenRefine use cases to see what we can use this program for. So here in our problem of example 1, messy data, a common enough occurrence, may be available or visible within our data files. Messy data often includes inconsistent formatting, typographical errors, or variations in how values are recorded. This includes common data entry inconsistencies that we've all probably seen before. Things like inconsistent date formats, misspellings, or varying capitalization. This kind of inconsistency can make analysis difficult and even lead to errors. So this is where OpenRefine comes in. In this use case, OpenRefine is a powerful tool for cleaning and standardizing data. It helps to fix the typos, unify formats, and merge together similar entries. It's especially useful for dealing with variations in data that come from multiple sources or manual inputs. So for example, you may have a column of city names that have been recorded in inconsistent formats, though they refer to the same thing. This could be New York with both words capitalized, or New York spelled with both words not capitalized, or the abbreviation NYC. All of these inconsistent formats really referring to the same thing. OpenRefine can help you standardize them all to one consistent format. So for example, just the name New York spelled out with capitalized first letters. Let's take a look at this spreadsheet to dive into this a bit deeper. As you can see, it's messy. In the second column, we have entries for a country, Korea, but they are very inconsistent. Some rows say Korea, N, others say North Korea, and some abbreviate the North or the South designations as NO or SO. In another column, we're dealing with organization names. Some entries say Department of State, while others say State Department. These refer to the same thing, but are recorded differently. This kind of inconsistency makes it hard to analyze the data. For example, if you wanted to count how many rows reference North Korea or filter by the Department of State, you'd miss some entries due to the inconsistencies. And this is where OpenRefine can help. With OpenRefine, we can use faceted search to identify all the variations for Korea and group them together. We can also use the clustering tool to unify the different versions of Department of State into one consistent entry. And we'll show examples of how this can be done. In just a few steps, we can clean this data, transforming it into a standardized and analyzable format. And this will save time, reduce errors, and prepare the data set for more meaningful analysis. So to build on this use case further, in example 1b, let's look at another table with a different set of issues. Here we have inconsistent date formats. Some rows use the month, day, year format, while others use year, month, day. A few even have the dates written out more completely, such as October 15th, 2015. In the next column, dollar amounts are a problem. Some entries have dollar signs, some don't, and others include commas while some don't, making it impossible to sort or calculate totals correctly from those numbers. And finally, we have a column for U.S. states, but the spellings are inconsistent. For example, Idaho is written as US-ID in some instances, or the word Idaho fully spelled out, but in different ways. These inconsistencies can cause big problems if we're trying to analyze or link this data to other data sets. Using OpenRefine, We can standardize all the date formats to one consistent style. We can reformat the dollar amounts so that they're uniform and ready for calculations. And we can clean up the state spellings by clustering and unifying the variations. In just a few clicks, OpenRefine will take the messy, unusable data and transform it into something clean, consistent, and ready for analysis. In example 2, our problem is messy categorical data. So like typos or duplicates or inconsistent naming, messy categorical data makes analysis difficult. Variations in the spelling or capitalization can lead to fragmentation within our categories and thus inaccurate results. In this use case, OpenRefine's clustering feature, powered by algorithms, groups similar but inconsistently spelled values, allowing you to clean and standardize the categories quickly. So, for example, if a dataset has product categories that are listed variably as seen here, the word electronics, first letter capitalized, the same word, first letter not capitalized, or even the misspelling of electronics, OpenRefine can detect these variations and automatically cluster the similar values together and merge them into a single, consistent entry for the category, such as the word electronics with the correct spelling and the first letter capitalized. Here's another example of messy categorical data. So in the fourth column, we see multiple variations all within the same category. The word female spelled all lowercase, a simple letter F, the word female spelled all uppercase. These inconsistencies can create issues when analyzing the data, as they might be treated as separate categories when they really refer to the same thing. OpenRefine's clustering feature can detect these variations and group them together, allowing you to quickly merge them into a single standardized value, such as the word female with the first letter capitalized. This ensures cleaner data and more accurate analysis with minimal manual effort. Now let's take a look at this screenshot from OpenRefine. This is the interface for OpenRefine's matching algorithm that's used in that clustering feature. It's designed to identify and group similar entries, even when they're written differently. In this example, near the bottom of the screenshot, we have two variations of the same item, mail bags. But in one case, it's all one word, and in another, it's mail and bags, two words. The difference is subtle, just a space and a capitalization, but OpenRefine's matching algorithm recognizes that these are likely the same thing. The tool highlights these matches, allowing us to quickly review and confirm whether they should be merged into one standardized value. And finally, in our final example, we have messy library data. So in library or bibliographic datasets, inconsistencies often arise in author names, titles, or publisher information. These inconsistencies can make it difficult to link records and perform accurate searches, or even generate correct citations. OpenRefine is a powerful tool that can address these challenges, especially through the clustering and merging functions we saw on the previous slide. These functions group similar entries for names, titles, or publishers, and they can standardize formats. For example, author names often appear in different formats, such as an author last name followed by their first and middle initials, or the other way around, first and middle initials and the last name, or maybe the whole full name spelled out, first name to middle names to last name. Titles may have differences in capitalization or punctuation, and publisher names may be recorded in different ways, such as Penguin Books, simply the word Penguin, or Penguin Random House. By cleaning the data with OpenRefine, the bibliographic records become consistent, enabling easier searches, reliable linking of records, and accurate citation generation. Now here is a look at the dataset we'll be working with today. You'll notice several types of inconsistencies. In publication type, some entries may use different terms for the same type of resource. Under publisher name, variations in spelling, abbreviations, or formatting can cause duplicate entries. And within the date formats, the dates often appear in multiple formats, which can make the sorting and filtering difficult. We'll use OpenRefine to clean and standardize this data efficiently, ensuring consistency and accuracy for analysis. And now at this point, I'll pass it over to Christine, who will show us with a live demo exactly how to carry out some of these functions. And I hope you will join us in working along with her.
Okay, thank you, Sarah. As we mentioned before, or if we forgot to mention, these materials are all based on the carpentries, from the carpentries material, and which is known for live coding. So if you were able to download and OpenRefine on your device, this is the time where we ask that you try to follow along with us. If you weren't able to, that's okay, and we hope that you'll still instead maybe take notes to follow along with at a later time. And we will be sharing the recording of this afterward as well. But now I'm going to share my screen. And hopefully I can get a thumbs up that you can see. Well, there's not much to see yet, but I'm going to launch OpenRefine, and again, if you're able to follow along, hopefully it looks similar to you. I'm using a Windows computer, and I'm using version 3.9.3 of OpenRefine, but it hopefully will look similar if you have a different version. But I'm launching OpenRefine from this blue diamond shortcut. You can also search for OpenRefine and launch for it in your program files. But for now, I'm going to double click that. And right away, it should open this like a black dialog box. We do need to leave this box open. It's the command prompt or console that'll be working in the background. I'm just going to minimize it for now. And then OpenRefine. It launched, should look like this. It should open in your web browser. It'll probably open in whatever default web browser you use. Oops, I'm sorry. Sorry, just trying to get my notes back up. So, and if you weren't able to launch it from the shortcut, you can also put in this server address into your, you can type this into your web browser and it should bring you to the OpenRefine site. But as we were mentioning before, or as we've mentioned, OpenRefine does not actually need the internet to work, and it's not actually does not actually manipulate your data directly. Instead, we're going to import our data into OpenRefine, and all the changes that we'll be making to the data will be stored within the project in a project file. And you can start and stop working on that project and continue it later if you like. You can also like create new projects in OpenRefine. And save and share them along the way. But we're going to start and import our data in just a moment here. Hopefully you were also able to download the data file. If not, hopefully one of our helpers today can put the link. It should send an email if you're able to download our data set with us. But the different data files that can be imported into OpenRefine include TSV, tab separated values, CSV, comma separated values, Excel files, what we're using today, JSON, just we'll be talking a little bit about later, XML, and even Google data spreadsheets. And now to bring our data set into OpenRefine, we're just going to be getting it from our computer. There's other options where you can import data directly from a web address or from another database. But we're today just going to be using the simplest option, which is using it from our computer. So we click Browse, and then wherever you have the data set saved on your computer is where you're going to click on that file, and then Open, and then Next. And it'll take a moment while it's there, while it's starting to load. And the first thing that actually, when you're importing data OpenRefine, the first thing it shows you is a preview of your data set. So this it's not actually hasn't actually been imported yet, but it's showing a preview of the data set. And we can see here that it's parsing the data as an Excel file. So OpenRefine is able to identify the file type and then shows you a preview of that data. So for an Excel file, there may be some processing that you want to do even before you import the dataset, even before you bring the dataset fully into OpenRefine. And for other file formats, you'll see other kinds of options here. But the one that we want to make sure is that for using an Excel file is that the first row of our dataset is being used as the column header used for our column headings. So you can see here the box is already checked for parse next one lines as column headers. So it means that the first row in our data set will be used as our column headers. And then if there were any changes made here, you can also update the preview just to again make sure that your data looks the way you're expecting before it is imported. And then we also want to note the project name here. So the project name, again, when you're using projects in OpenRefine, it'll default to whatever the name of the file is. So this is the name of the file of the data set. So I'm just going to rename this so that it's a little clearer for future purposes. And it's also helpful if you have like multiple files that might have the same name, or if you just want to keep track of your projects. It's nice also to like add a date to it somewhere, but you can change the project name here before you've imported the data. And so once we've selected all of our options and we've checked our preview, we can create the project. And so right away, now we have our data set in OpenRefine. And I'll just pause here, and if I can get a couple of thumbs up, hopefully showing that people are with me so far. See that Javier has dropped the link in the chat in case you need to download the data set. Okay, I'm seeing a few thumbs up. Please do let us know if you're having troubles, and our helpers will reach out to you. But as I mentioned before too, project files will be, so the projects in OpenRefine, it's actually saving as you go, so there's no button here to save anything. There's no need to save copies as you're going along. However, we will end today's class by exporting our data set and saving a new data set from what we have accomplished. So OpenRefine displays data in a tabular format where each row usually represents a record in the data, while each column represents a type of information or a variable. This is very similar to how you might view data in a spreadsheet or a database. And as with a spreadsheet, the individual bits of data, those that are in the cells, the intersection of a row or a column, that's our actual data. OpenRefine only displays a limited number of rows at one time, so you can see it defaults to 10. So it's showing, if I scroll down, it's showing the first 10 rows in the data set. And but you can change this if you wanted to show only 5 rows or only, I'm actually going to set mine to 25 rows because that's a nice number to look at one time. And you can all navigate through the rows. You can also navigate between, you can navigate using these first, previous, next, and last buttons. These will take you to the next 25 rows, or the next, or you can jump all the way to the bottom of your data set by going to the last. We'll show like the last rows, but I'm going to go back to the top of our data set. And OpenRefine has 2 modes for viewing data. There's rows, which is what is defaulted, and then records. And at the moment, we're in the rows mode, where each row is representing a single record in this data set, which in this case is, these are each articles from a systematic review search. So a row is a simple way to organize data with a series of cells, one cell per column. But sometimes there may be pieces of information, more than one piece of information in a data set at a time. So as we looked at some of those examples with Sarah, sometimes there can be some messiness in our data. So for example, looking at our author column, we'll see that there are multiple authors for many of these articles, and their names are separated by a slash. It is possible in OpenRefine to separate out these multi-valued cells. And another column we can see that has this is the subject headings, where there's many subject headings listed. It is possible to separate these out in multi-value cells, and that's where using the records to viewing the records together, where OpenRefine can link multiple rows and show as them belonging to the same record. So rows will be assigned to records based on the values in the first column. There's more on this in the OpenRefine documentation, and we can either share that link or it'll be sent out with materials afterward. But essentially what we're going to be doing today is staying in the rows method, or staying in the rows view, and we have 3,189 rows in this data set. Again, that's 3,189 articles that are in this data set, or bibliographic records represented in this data set. So now that we've talked about rows, I'm going to talk about columns. So most options to work with data in OpenRefine are accessed from these drop-down menus at the top of each of our data columns. So when you select an option in a particular column, for example, to make changes to that data, to make changes to the data in that column, it affects all of the cells in that column, but only that column. So if we wanted to make changes across several columns, you would have to do this one column at a time. One thing that we can do actually that allows us to kind of work on multiple columns at once is we can reorder our columns. So I'll show you how to reorder and remove columns. We can reorder columns by clicking on the drop-down menu at our very first column, which is actually labeled as all, and we want to do edit columns and then reorder/remove columns. Now here, there's a pop-up window that shows our list of columns, has the list of the columns in the current order. And then you can see here you can drag columns over to the side to remove them. So I actually do want to remove two of the columns from our data set, this column 24 and column 25. These are actually empty extra columns that were added in Excel, but they don't actually have any data in them. So I'm moving them over to remove. And then I also want to, you can also drag and drop your columns in this window to reorder them. So we're going to be using the date column. We have two date columns in this data set, date of publication and date accessed. We're going to be using those more in session 2, but for now I'm going to reorder them just so they're closer at the top. Just move them in our data set. So I'm going to move them data publication between source and title, and the same with data access. I'm going to drag it up to be after date of publication, before title. So once I've made those changes, I click OK. And now you can see it's reordered my columns, and my date of publication and my date access are now have been moved from the end of the data set to kind of in the middle, closer to the side of it. So one more thing in columns is that you can also rename them. And here again, this we have to do just with one column at a time. And again, using my date of publication column, I want this, I can rename this column to match closer to date accessed. So using the drop down for the date of publication column, I go to edit column and then rename column. This opens that another little window where I can type in a new column name, and I'm going to just change this to be date published to match our date accessed. And then click OK, and let's change the name of the column. If you that's navigating the rows and columns in OpenRefine. And we're going to move on now to looking at sorting based on a column. So if you've used Excel before, you're probably familiar with being able to sort rows based on a particular column. And similarly, we can sort data in OpenRefine by clicking on the drop-down for the column that we want to sort on and choosing sort. So I'm going to sort based on our title column. And we use our drop-down and then sort. This is opening a pop-up box again, and you can see that it's asking sorting values as text, or as it's asking if we're going to sort the cell values based on text, based on numbers, dates, or Booleans. Since this column is text data, we can leave the text box checked. And then you'll see that by default it's going to sort from A to Z, so alphabetically. And I'm going to leave that box checked, and we can ignore this position blanks and errors. And I click OK. So now you notice our title column, that it is sorting. It may initially look like, oh, did it actually sort it from A to Z? But what it's actually doing is sorting based on the first character of each title. And so there are titles that start with a quotation mark. Here's a single quotation mark, and then 2 quotation marks. And then as we continue on, we see that there's a bracket, and then we finally have like our first entries that start with a letter A. So there's actually a lot of entries in this data set that start with a bracket. But we can see now that the first but it is sorting based on alphabet. Unlike in Excel, when you sort in OpenRefine, it is temporary. So that is, we can remove the sort. If we remove the sort, we haven't actually changed the order of the rows in our data set. They will go back to the unordered state if we were to remove the sort. So there's right above, right next to our number of rows, we can now see this little sort drop-down. When we open that drop-down, the first thing is to remove the sort. And then there's reorder rows permanently. So again, as I mentioned, sort is not, it's not actually changing the order of our data set. But if we wanted to change the order of our data set based on a column, we could reorder the rows permanently. And then you'll see by title, and this is by the column that we're sorting on. You can see again, this sort, if I click this will open our sort window again, that little pop-up box where we specify what the sort was, or we can reverse the sort. And reversing the sort will do kind of what it sounds like. It'll, instead of sorting from A to Z, it sorts from Z to A. And so we can see here the very last entry, Zika virus, starts with Zika virus, and then you can see it's continuing backwards in the alphabet. And then the very last, and again, that remove sort is is also part of our sort menu. So I want to make sure that everyone is able to stay with me, and I'm gonna do, we're gonna do our first exercise together. So I want to, I'm going to this time sort based on our author column. Should we scroll to the right? Nope, it was right there, the author column. And I'm going to sort now based on the author column. So again, going the drop down, sort, leaving these defaults checked, okay. And then if you're able to, like, put in the chat, what is the article title that's the third from the top? So after you've sorted based on the author column, what is now the third column title? All right, I'm seeing in the chat people, yep. If I scroll down a little, you will be able to see it, but the third article here is now monitoring airway pressure in pediatric anesthesia. And the author there is, starts with A. So that was a good little exercise. And we now have our first practice question. So I'm going to remove the sort again. And our practice question, we want you to want you to try this on your own, and then we'll go through it together, is to use the sort on the language and publisher columns, and then to tell us, and you can put this in the chat, what is the first entry in the publisher column and what is the last entry in the language column? Okay, looks like I'm seeing some responses in the chat. Some have said the AAN Publishing Inc. I've seen a couple of different languages. So I'm now going to go through the exercise, or go through the problem together. So we removed our sort from the author column, and we are going to look at we're looking at our publisher and language columns. So first we want to know the first entry in the publisher column, so I sort, and that is there. Yes, the AAN Publishing Inc. It looks like most people have got that one. And then looking at our language column, so something I maybe didn't mention is that sorting, you can sort by more than one column, but it will sort first by the first column that you've sorted. So if we now sort the language column, it'll let us do this, and we can actually even we can sort, because we want to know the last entry in the language column, we can change this to Z to A, because that'll tell us the last language in the column. And you'll also see this box now that wasn't there before, sort by this column alone. So this, it's kind of giving us this option because we've already sorted by one column. So we need to either to tell it to sort by this column alone, or it's going to still be sorted based on the publisher column first, and then it would be sorting by language column second. So I am going to click this box to sort by this column alone. And when I do that, I do get the language column sorted or I do get the last entry in the language column being Ukrainian. And again, when you have more than one sort, you'll see a second sort appear, like by language, it would have by publisher. And that's where you can like change then like which one it's sorting by. But it just can be a little tricky because there's, it doesn't sort exactly the same way that it does in Excel. And again, as I mentioned before, that when we have a sort, we might want to decide to, oh, well, that was one thing too, is that if you sorted instead by language, and I think someone did say that they had originally maybe sorted and had gotten the first entry, is that if we reverse this sort, that would give us the first entry in language. Or if we had originally sorted by A to Z and then we wanted to reverse the sort, that would give us back to the Ukrainian. But also, what if I'm clicking in here and I accidentally click reorder the rows permanently? And as I mentioned before, when you reorder the rows, it's actually changing the order of your rows. And this is one way if you did want to sort by two columns and you just wanted to change the order of your data set based on the first column, and then you wanted to sort after that on a different column, you could do that. But when I reordered the rows permanently, it did actually change the data set. And so let's say I didn't mean to do that. I was just clicking around. We can go to our undo redo tab on our left-hand pane here. And you can see that OpenRefine is keeping a log of the steps that we've taken on our data set so far. So OpenRefine lets you undo and redo a number of steps that you've taken in cleaning your data. So you can always, if you do make a mistake or just trying things out, you can always undo if needed. So the way it's recording these steps, it also is recording these steps, and you can also repeat these steps on another data set in the future. We'll hopefully look at that at the end of today's class, how you can save the steps that you've taken and use them on another data set. But for right now, I just want to undo my reordering of the rows. So what I would do is just click back on the last step that I do want to save, the last step that I do want to have taken. And you'll see now this reorder rows has become grayed out. That means that I can reapply it if I said, oh, actually, no, I wanted to reorder the rows. I could undo it then, or I could redo that action. The only thing is it only lets you undo and redo in one set of steps. So likely you'll see the next time I do want to make a change to the data set, it's going to ask me if I'm okay with deleting this, this step. So it'll make more sense when I do my next step, but that's a little glimpse at our undo redo. And in case you are working on this for the first time and are like, oh, I made the little mistakes, like it's easy to undo and redo and OpenRefine. So our next big topic in our lesson is looking at facets. So you'll see there's this facet and filter in our menu in our left-hand side as well. And facets are one of the most useful features of OpenRefine that can help both in giving you an overview of your data and also to improve the consistency of the data. So a facet groups all of the values that appear in a column and then allows you to filter the data by these values and edit values across many records at the same time. So we think of all the examples that we saw that Sarah was showing us of where there's small inconsistencies. Facets can help with renaming those. So one of the most commonly used facets is called the text facet. And this will group text values in a column and count how many times each value appears, similar to a pivot table in Excel. We are going to do a facet on our journal name column. I scroll back to this way. Journal name column. And to create our text facet, we're going to use our drop down and then facet and then text facet. This facet will then appear over here on our left-hand side, and right away we can see that there are 709 choices that it found, and this corresponds to 709 unique journal names. You can opt to order these alphabetically, that's what's default. They're ordered by name or by count. When you order by count, it'll give you the most frequently occurring facets in that column. If we hover over one of these names, you can also, as we're hovering over the names of these journals, you can also see there's buttons to edit or include. And you can include multiple values from the same facet in a filter at one time by using the include option. And you can also edit facets to change the values of several records at the same time. So I'm going to scroll down to anesthesia, and analgesia. And it's a little confusing because it's spelled many different ways, but anesthesia and analgesia, there's actually two entries here where one is written with an ampersand and one is written with the word and. And so here I can click include and include, and now I've included both of those. Entries. So now I'm seeing a total of 175 rows matching these two entries. But as I mentioned, you can also edit entries here. So if I see that this is occurring more times, the ampersand, I can click edit next to this this journal name, and I can actually change the name for those records, typing anesthesia ampersand analgesia and hit apply. Oh, and this is what I mentioned before, that when I do this, it's going to ask me to confirm that I'm overwriting the history entry from reordering the rows. And I do want to do that because I didn't mean to reorder the rows. So it's okay to apply anyway. It just means that now I can't go back and reorder those rows. It's only one stream. Only allows you to edit in one stream. So now you can see that all these 175 rows have actually collapsed into just one entry in our facet list. I want to show you too that as I mentioned before, when you click when we sort by the count of our facets, it'll show us the most the top 3 journals in this data set. So, and right at the moment, I only have anesthesia and analgesia selected, but I can also include, I could say I wanted to look at just the articles from these top 3 journals, or I wanted to know what the top 3 journals were on this topic that I was searching, and then look at those articles alone. I can see that combining these 3 facets together, I have 787 rows. So, there's ways that you can think of that being useful. And then if you also say I found the top three journals in this article, top three journals in this data set, but I want to now look at the rest of the data set. You can also invert what you've selected. So, right, we had 787 rows. If I invert this, it's actually now showing me, it's actually excluding these three journals and showing me only records, only rows for only these journals, the up to 2,400 journals that are not in those top three. It's important to then hit reset if we want to reset this, because when we have only selected a certain number, it's actually only then showing us, when it's only showing us those selections of rows, then any future steps that we take are only going to be acting on those selected rows. So we've reset the facet. We're back to having our 3,189 rows, and we'll move on to our next practice question. Or actually, we'll do an exercise and then a practice. So I'm going to just X out this facet, and now look at our publisher column. Back at our publisher column. Nope, it was right here. And again, we're going to do the facet, text facet. And when I look here, I can see that, again, it lists, this time there's 247 different publishers. And we can kind of see that some of these definitely could become we could edit some of these, like this, for example, has the address typed out. I could delete that, and that would combine it with American Academy of Pediatrics. Now the numbers changed from 4 to 5. You could select certain publishers. When you click on the titles, it only selects one, but if you click one title and then you click include next to it, that's how you can include multiple of your facets. So I could invert this if I wanted to exclude those for whatever reason, and that's where now the number of rows has changed. And when I X out of that, it brings me back to all of my rows. So now we have another practice question for you. This time we want you to look at the country of publication column and answer two questions. How many countries are represented in this data set, and how many articles were published in the United States? So this is based on the country of publication column. We'll give you a minute or two. I will check the chat for any things we missed. Or feel free to put the answers to those questions in the chat. All right, great. I'm seeing answers coming in the chat. I also saw that there was a question about including more than one facet. I can show that again. And then someone was asking about the ampersand. Something I wanted to mention is that when you're looking at the facets for these, this is where having a controlled vocabulary is super helpful, because then if you already know what the journal name or the publisher name, the actual controlled vocabulary name is, then you know what to change when you're knowing which of the facets is supposed to be the actual consistent journal name. I don't know if that answered that. But all right, it looks like lots of people have gotten the numbers for our country of publication column. So I'm going to go to that column. And we'll do use our text facet. And I can see right away that there's 64 choices for this. And we may already have noticed, though, or you may notice as you're scrolling through the facet list, that there are some countries that maybe are duplicates, it could be combined. But for just the exercise purposes, we see that there's 64 different countries that were the country of publication. And yes, somebody pointed out that there's almost 200 that are blank. And then how many articles were published in the United States? We can find that by scrolling down to where the United States is. You can see 858 records or rows. The number is kind of there right next to it. We could also select it and see 858 matching rows. The other way you could have found it too is by looking at reordering by count. And actually this shows us that the US is definitely the country with the most publications in this data set. So as we're talking about facets, there's other kinds of facets that that OpenRefine supports, not just the text facet. There's also numeric facets, timeline facets, which work specifically on dates. There's a scatter plot facet, and then custom facets. We won't be looking at numeric facets or the scatter plot. We will look at timeline facet in session 2 when we work more on dates. The customized facets also offer a range of different types, a range of different kind of things that you can facet by. And 2 of the default customized facets are faceting by duplicates and faceting by blank or null values. So as we're mentioning, as somebody's pointed out, like there are blanks in some of these. We can actually facet by look at just blank values. We'll start with the duplicate facet though, and this time we're going to look at our DOI column. So say, for example, that we wanted to see how many DOIs are duplicate. This might help us with deduplicating records in a data set. And we can use the customized facet. So how we get to that is from our drop-down facet and then customized facets and duplicate facets. So it's the second one down in that menu. And how these facets work is that they actually create a binary. It's a true or they generate a true or false value, where the rows that it appears true is if the value in the column is an exact match for another value. So this is telling us that there are 788 rows where there is duplicate. This is good for knowing if you want to remove your duplicates before analyzing your data. But something else that we might notice when we click on looking at these values that are true or have duplicates is that there's also a lot of blanks. So before we go ahead and remove all of these, we also might want to see we might want to facet by the blank. So we do facet again, customize facets, and facet by null. Oh, and this is and I didn't close my other facet out, and this is where it can be a little confusing if you have a lot of facets at once, especially when these are both on the DOI column. So I know because we just looked at it that this first box here was our faceting by duplicate. I'm going to close that. And then here we have just our facet by blank. And this time it's a binary showing us that the true values, there's 631, where it's actually the DOI column is blank. And we can confirm this visually by, we look at the 631, we can see that there's nothing in those cells. So if we, these kind of facets can help with if you're quickly trying to determine if you have missing or duplicated information in your data set. And we have one last practice problem for you that's going to be faceting by blank, using the blank facet. Using the faceting by blank, you would want to use the facet by blank on the abstract column. So our abstract column, and we want to know how many records do not have an abstract, or in this case would be marked, or in this case are marked true. All right, people are getting that answer. It's not on this. Yep, looking at our abstract column. I'm going to close the DOI facet this time because I don't want to confuse myself by having 2 facets open. I'm on our abstract column, facet, customize facets, facet by null. And this time I can see 789, yes, or 787, sorry, that's the answer everyone was getting. 787 is the number of articles that don't have an abstract. And again, that could help if you were doing this think of use cases where it's oh, well, there's no abstract, I'm going to exclude that from my my search. I'll close that now. And similar to facets, we also can filter data in OpenRefine. And what a filter allows you to do is to actually search for a particular piece of text that appears in a column, and then kind of limit similar to facets where you can limit to those number of rows, you can limit based on that text, what the specific text that is in that column. So it's similar to a find feature. or like Control F. And for this, we're going to look at publication type column. So again, our drop-down text filter. And so this time, instead of it showing like a list of all the different values, I can type in the value that I'm looking for. So I'm starting to type conference, and as I do that, you can already see before I even type the full word that it's limiting the number of rows. So it's showing me 382 rows that have conference somewhere in that column type. So conference abstract appears to be a recurring publication type for this in that column. So we can, as we did with facets, we can also invert this search. So like we searched again, we're only showing us this many rows based on what we've filtered to, but we can invert it and it will now show us all of the rows where it does not match this, does not match what we've searched. So there's no conference that will appear in this publication, in these ones. It's articles, it's reviews, editorials. These are the publication types that we're now seeing. And I want to make sure when I've finished filtering and I've examined it to reset the filter, and I can or you can also close this and it will bring you back to your total number of rows again. It's important to note that when we're filtering, when we're faceting, that when we are looking at the number of rows that are being displayed, those are the rows that will be active, that will have different things, operations carried out on them. And it's good to just check regularly that you're still working on it's a way that you can subset the data that way, but then if you want to go back to like working on the full data set and making changes, then you want to make sure that you've cleared any filters or facets that you've created. So I'm going to do just another exercise on the filter, and this, let me know, or I guess, let's look at this one together, and then we'll take another. So I'm going to do a filter on the mesh subjects headings. And here again, we do text filter, drop down text filter, and I'm going to start searching for human. And then give me a thumbs up if you were able to follow along, or if you're with me. Give me a thumbs up if you're with me, and if you've been able to use the filter on the mesh subject headings column. I guess I should also say, if you're not with me, you can give us a thumbs down, and then again, we can either try to help you if you're getting stuck, or yeah, I'm seeing mostly thumbs up. So, but yes, when we start searching human in our mesh subjects heading, we have 2,708 rows. And as we said before, there's a lot of different, these are multi-valued cells, multiple subject headings for each of the articles. And this is when another thing, if you can think of it as another use case, we said, where if you're searching for human, or you have a search term that was essential for your search and it's missing, like this will also, when we invert it, it'll show us that there's 481 records where it doesn't mention human. So if there's like an essential search term that is missing from some of these articles, we could exclude these again from our data set. So that's some of the uses for the filter. I've X'd out of that again to bring us back to our full data set. And then our last big topic our last big thing we want to show you is using the clustering. And this was something Sarah showed you a preview of in our slides, that we can use clusters. Using the cluster feature groups together similar but inconsistent values in a given column and lets you merge them into a single consistent value. This is very effective when you have data with minor variations in data values, such as like the names of people, organizations, places, classification terms. If you think of, just some journals may start with the word the, or they may not. How there's many different ways to abbreviate the United States, or like just different inconsistencies that can be different messiness that might appear in your data set. So we're going to use the cluster function. To use the cluster function, we're going to, it's in our drop down, and we pick our relevant column, which is going to be our publisher column. So we use our drop down, and then we go to edit cells and cluster and edit. So clusters are created using according to an algorithm, and OpenRefine supports a number of different clustering algorithms. So some experimentation may be required to see which clustering algorithms work best for any particular set of data. You may find different algorithms highlight different clusters. Again, there's more reference on this. There's more information on this in the OpenRefine's documentation. And there is some trial and error that may need to be involved with finding like the right algorithm for clustering. But right now, we already have the method set for key collision. I'm going to set my keying function to the n-gram fingerprint and then click cluster. So as you can see, it's found 4 clusters for us. And for each of these clusters, you can see that there's options for merging the values together. And it shows you the values that are in, like it shows you the different kind of values or clusters that you might have, or the different values that are in that cluster. And then it also shows you a new cell value. So by default, OpenRefine is going to, it's going to select the entry that has the most, that appears the most frequently in the new cell value box, but you can also edit this text that's in the new cell value box. So if it was actually supposed to be like Biomed Central Limited instead of abbreviated, or maybe there's supposed to be a period on the end or there's not supposed to be a period on the end, you can actually like if you select the entry that you want to be the new cell value, it'll fill that in. And it also is showing you the size of the clusters and the number of rows that are being affected. So for this, I'm actually going to, I'm going to click merge for Biomed Central Limited and the Institute of Medical Legal Publications. And then I'm going to merge selected and recluster. Because I'm not done clustering yet. I want to, it's just merged together to the 2 clusters that I selected, and it's showing me the other ones that are still here. And then I actually want to try a different keying function, because as I mentioned, they can sometimes find different kinds of clusters. So I'm changing the keying function to Metaphone 3, and click cluster again. And now actually there's a lot more, this one picked up a lot more clusters, 42 different clusters. And you can see there's a lot of different a lot of different entries for some of these. This is sort of where I mentioned again, like having a controlled vocabulary, knowing what it can be kind of harder to tell then, because it's like, well, are John Wiley and Sons Inc. the same as John Wiley and Sons Limited? Like, are those actually the same publisher? It can help to also look at the rows or look at the records to see if there's other ways to confirm that they are the same, that they're from the same publisher, have the same meaning. So for Lippincott, Williams, and Wilkins, I scroll, and here we have to scroll over because the entries are so long, but we can see the new cell value has no punctuation. Again, it's showing the cluster size. This one had 7 different facets, and then it actually 170 rows are how many rows are in this cluster. So I'm actually I am gonna merge this cluster. And this time I'm going to click merge selected and close. And now you can also see mass edit 170 cells in column publisher. So this is, again, you might have seen this as you were going through, that each time we're making changes to the data set, it is like recording those steps that we've taken. It's also it is always a good idea to double check those clusters, as I was saying, like to make sure that you before you're merging things that they are actually the same. It's because sometimes it will get clusters. It may try to cluster things that are not actually the same. So as I was saying before, like you can see this mass at 170 cells in the column publisher. You can see the other, like when we did the clustering the first time, it edited 7 cells. We can see that record of the steps that we've been taking throughout today's session. But as we're getting close to the end of the class, I do want to show you how you can save all of these steps. So you can, as I said before, you can use this to go back to like different older versions of the data set, but you can also use these, you can also copy the record of these steps that could be used on for future cleaning and formatting of data on different spreadsheets. So how we would do that is if we click extract. So if you want to save your steps for later, clicking extract opens this operation history where you can see these are all the steps so far that we've taken. By default, they'll all be selected. And then you can also see here, this is, I'll just make sure I want to copy it before I click on it, but this is all written in JavaScript object notation, which is JSON. This is like kind of what's happening in the back end of OpenRefine. But we can save all these, either you can copy this like into a text file, or if you hit export, that'll actually export it to a .json file, which you can open in any kind of plain text editor, any plain text editor. So I've saved this here, I've saved my steps here, I can close that. And then if you had another data set that you wanted to apply these same steps to, we can actually click apply. And this probably is something you would do if you had like a new project open, or if I had more steps for the future of this, working on this same data set, I can actually copy, and here I copy pasted everything that was in that previous window. Or again, you could browse and upload a plain text file, or upload that JSON history file. I'm not going to do this now because we've already made all these changes on this data set, so it actually might have it might not be able to do that again. But you would run operations, and that would allow you to run it on a future, on another data set, like to repeat all of these steps that we've taken today on another data set. I'm going to cancel out of there. And as I had mentioned earlier too, that the undo redo data, these steps the data that's here is actually, it's stored in with your project, which is saving automatically as you're going. So the next time you open this project, you should still have this full history of steps here to carry out and undo and redo in exactly the same, like moving backward and forward in the data, moving backward and forward on the steps that you've taken. But now as we're finishing up, we're finishing up the demo, but we can also take a few minutes for questions. I'm going to show you the very last step for today's session. It's going to be exporting our data. And again, like the file itself is saved, but if we want to actually save the new data set that we've created, like we've made these changes, and again, it's not actually editing the data, it's not actually changing the data set that we started with. We haven't actually saved the data into a data format yet. But there's export at the top right corner of our screen, has a drop down, and again, you can export your whole OpenRefine project to a file, and like you could save that and share it with collaborators. You could open it on another computer that has OpenRefine. Like there are times when you may want to save the whole project as a file as well. But if we're just wanting to save the data, you can see that it also has different data formats we can save in. There's HTML, CSV, TSV, and what we're going to save it in as today is what we started with, a .xlsx file. So when I do that, it just saves it, downloads it, and it's going to download it with the name of the project. And I've already downloaded something with that project name, but that's how you save your data from OpenRefine. As just a last note too, as we mentioned before, when there's, it's easy, what we actually download, what we actually just exported is this full data set. It's the number of rows that are appearing in OpenRefine at that time. So it's a little bit too easy to export a portion of your data set by accident. There are also times when you may want to only export a portion of your data set. So it's good to check the number of rows that you have visible is going to be the number of rows that is present in your full export. So, but I think I'll stop talking, and we have some time for questions. We have more time than I expected, but I will stop sharing. And Javier, are there questions that we can answer that have not been addressed in the chat?
There is one from Tanika. It is, if you have a controlled vocabulary, how would you incorporate it into the data in OpenRefine?
That is a great question, and I don't initially know how, but I have to think there is a way how. Maybe I think it's partly that like when we're working with, I mean, mesh subject headings is a controlled vocabulary, but we can see that like they're we'd have to do a lot more. You'd have to do a lot more processing, separating these out to work with them. And sorry, I'm not sharing my screen anymore, but with the yeah, it's a great question. I think there may be a way to do it, but it's probably not like an easy, like, here's my control vocabulary, match everything in this with that.
Christine,
But
would you say that the reconciliation process is like that? Reconciling data?
possibly. Yeah, actually, possibly.
I'm
I
going to
might
drop the
actually
link
use that
about that.
myself. Yeah, please
Yeah.
do. Yeah.
I'll drop that in the chat. And the documentation there will be pretty important to check out. Sometimes it involves accessing endpoints through APIs. So if you're able to read up about that, it can be a good function as long as it meshes up nicely with OpenRefine.
Yeah, great. Thank you for sharing that link, Sarah. And in the chat, there's also the link for the feedback survey. Sorry, we didn't put a QR code on this slide, but if you're able to give us your feedback, the link, I think Javier just shared it again. And we will we'll likely share out the slides that we had today, as well as like our documentation of the demo that we did, just the steps that we were following. And that has some links included on it to further documentation on from OpenRefine. So hopefully, if you're wanting to learn more and try more of those complicated, try some more complex things. And if you are joining us next week, we'll be kind of picking up from what we did today and looking at doing transformations, which is, and if you are joining us with part 2, the data set that you just saved, hold on to that because that is what we'll use in part 2. So hopefully we'll also get an email out to everyone who registered for part 2 of this is the data set we're working with. But if you have it, if you're here today, then you already have the data set. Thank you for joining us today. I just saw another question. Is there a resource listing standard data cleaning steps for bibliographic records? Do any of my other helpers, instructors have knowledge of that? It sounds like that it would be great if there was a resource for that, but
Yeah, I'm
I'm not
afraid I
aware.
don't have one, unfortunately. Every data set is usually so different that sometimes the approach to the cleaning steps, that might be really different from case to case. But that is a great idea to bring up. Maybe we can identify one.
Yeah, I also cannot think of that, but maybe there are some forums or other platforms where people discuss those things and share sort of common steps, but I'm not too familiar with it. I'm just thinking, usually coders will share common code for certain types of data sets. There's probably something like that, but I'm not familiar with it right now.
Thanks for watching. This video was produced by the network of the National Library of Medicine. Select the circular channel icon to subscribe to our channel or select a video thumbnail to watch another video from the channel.